Prove that the difference between the squares of any two consecutive integers is equal to the sum of these integers. Okay, first let's try an example. So let's try 3 and 4. So if we do 4 squared minus 3 squared, that's finding the difference between them. That will be 16 minus 9, which will give me 7. If I add 3 plus 4, then I'm going to get 7. So it seems to work. Okay, but that doesn't prove it for every single case. So we now have to prove it for all cases. We will need to use some algebra. Okay, let the first integer be n, and then the next integer, because it's consecutive, will be one more, which will be n plus 1. So if we now square these, so n plus 1 all squared, minus n squared, that means n plus 1 times n plus 1 minus n squared. Now, it depends on how you expand these. One way is to do n times n plus 1 times n plus 1 and minus n squared. So we're going to get n squared plus n when you multiply that, and 1 times 1 gives you that, minus n squared. So that gives n squared and the minus n squared will cancel out. Therefore, you've got n plus n, which is 2n plus 1. Okay, what happens if we add these two integers, n and n plus 1? So if we add them, we're going to get n plus n plus 1, which is going to give me 2n plus 1. So we've got the same thing. So now we proved it for every single pair of consecutive integers. And therefore we could write out the conclusion. So the difference between the squares of any two consecutive integers is equal to the sum of these integers. Okay, so this has been a video to show you how to prove the difference between the squares of any two consecutive integers will be equal to the sum of those integers. I hope you've understood, and I thank you very much for watching.